want to use or what type of instances you want to use. You still have that option if you want to specify that. But if you don't want to, you can have ML Engine figure that out for you. It also does prediction as well as training. So after you train the model, you can set it up just to do online prediction or batch prediction. So you don't have to think about where you're going to host your model for the production workload. And there's no lock-in. So when you build a model, you can just export out of ML Engine. And if you won't have the need to use that model in your on-premise environment, you can easily do that. So one thing I kind of skipped over was accelerators with GPUs and TPUs. So GPUs, you probably have already heard of the graphical processing units. Nowadays, folks are kind of matching that GPU with cryptocurrency, Bitcoin mining, and all that. But there are a lot of other use cases for GPUs, and one of them is to use it for machine learning. Right? But what we did was we actually had something called TPU. So TPU is tensor processing unit. It's a piece of hardware that we developed internally for our own use initially. And the reason why we had to develop our own custom hardware for this, for machine learning initially, was because this engine is a Mac. What they did was they said if everyone in the world holding an Android phone using voice search for 3 minutes a day, we'll have to double our data centers in order to support that type of workload. And earlier we talked about the infrastructure that we have. Think about having to double that. That's a lot of investment. So instead of doing that, what we ended up doing was we developed these custom chips that allows us to accelerate the prediction of, for example, for voice recognition. Okay? And what we did done with that was version one of TPU that we use internally. But then we released version 2, which is what we're looking at here. It's hard to tell from looking at the picture, but those are heat sinks. And these heat sinks are about this big. These are not small boards. It's not a little tiny sound card. These are a huge board. But what we've done is actually, this is version 2, and we just released version 3, which instead of using heat sinks, we're using water cooling. And we're able to do more optimization to give us, I think it was each of these, so under here is one TPU. Each of these, I think we can do 11 petaflops, but you can link 64 of these entire cards together into what we call a TPU pod. It looks like a supercomputer, and that will give you hundreds of petaflops, so it's quite amazing. And customers love these because earlier I talked about speed is super important nowadays. Most data scientists, and I'm not a data scientist, so I'm just hearing what others are telling me, is that you need to experiment, you need to test, and you need to use a lot of data in order to build good models. And so if you have hardware accelerators that will give you opportunities to do more experiments and try different things, this will give you the ability to build better models. Right, so we covered machine learning engine, or ML engine, and TensorFlow at a very high level. But there are other ways that you can build smart applications on GCP. Right, so we have these pre-trained ML models. You can access these through machine learning APIs. And these are based on, these models are trained based on our own data, our own private data. And so what do they do? Right? So there's actually more than these. This is a slightly older slide, but we can do things like vision. This is called vision API, so take an image. I'm going to show a demo of this later on. Maybe I'll do that instead of, I'll do that instead of showing you. But these two I don't have a demo of, so let me quickly talk through this. Video intelligence is where you can upload a video file, and we can basically go through the entire video and tell you what's in the video. So it's great to be able to take what we've seen is that customers have these archives of videos and they want to know what's in them without having someone to manually tag and remember what the right descriptions and all that. So we can pass it through the video intelligence API. We can figure out what's in them. Jobs API is great for if you have HR, human resource type applications you want to improve on, you can use that. So let me just go into a demo of some of these. Not sure how well this is going to work because it's a little dark. Here it is. So this is using the Vision API and is able to recognize that, well, actually I select the faces. So
Do you want to open the light just for the demo?
Let me see if this is working first. Let me see if I can pick up that joyful.
Okay.
It's not picking it up. Oh, you can just trust me that it works. Maybe that's better.
Oh.
Is this working? That would be right. Okay, there you go. Maybe it's the light. It's unlikely that I'm unlikely. Let's try that again. It's not working. Okay. Oh, very likely. There you go. It's working. Yeah, so I think there's just a bit of lag. Maybe it's the Wi-Fi. Always blame it on the Wi-Fi. But you can pick out whether someone is happy, sad, surprised, or others. Yeah, I think it's definitely the Wi-Fi because normally when I run this, you see a square, and sometimes you see it flashing on the screen right now. But it would basically it's taking a lot of different pictures every half second, and then sending it to the Vision API to pick up, whether I'm happy or not. You're getting serious. I am serious. Okay, let's try the label now. So it's able to see that I have hair, which is great. Let me see if I can pick my phone. Is it able to see that I have a phone? It's able to pick up my hair. It's able to see my chin. Anyway, so let me show you another demo with this. So this is this is right on our website. So if you look for Vision API, Google GCP, there's a section here that you can try out the API. So what you can do is, what I would do here is I'll take, I have a picture of this. So this is an X-ray, of course. And so if I pass this into the Vision API, let me see if this is going to return something. There you go. So it's able to recognize this is a medical radiography, it's an X-ray, it's black and white, etc., which is great. But this is not necessarily going to help you for your use case, right? So what we did was, let me go back to this slide for 1 second. So you notice that I have something called AutoML here. So what we've done is that we took our pre-trained machine learning models from the Vision API. We peeled some layers back, but allowing you to add your own custom data with your own things that you want to predict and passing it into the AutoML service to build your own custom models for your own use case. So my example was, I want to predict whether someone has pneumonia or not. Now, you should still see a doctor and not use this model to figure out whether you have pneumonia or not. Not trying to get rid of doctors there. But this allows you to build your own custom machine learning models for the images that you have. So I took some public data sets, and these are examples of what pneumonia looks like, and the one that we're looking at here actually does have pneumonia. And so passing it to this service, and also that's all the different images that I have, which includes close to 6,000 images. But there are some images here that would say, if I scroll down far enough, of healthy lungs, right? And so after I pass the data in, what I can do then is I can say, train the model, you can train it for an hour or 24 hours, and then it will just automatically do all the training for you, and then you can take a new image of an X-ray, passing it into the service, and predict with some level of confidence whether this particular, for this use case, would be whether someone has pneumonia or not. Right? So I'm not going to go through the entire flow because I'm running short on time, but this is a really neat service. Now I just want to quickly try another demo here. So the vision one wasn't working very well. But this one seems to be working better. It's able to pick up my speech as I go. So this is the natural language processing API. What it does is, just refresh it. What it does is it actually takes the words that's coming out of my mouth and it's able to say, what is the sentiment on what I'm saying, whether it's positive or negative. So let me try this. It's recording. Oh. I like GCP. So you can see the sentiment is around 0.3, so that's fairly positive. Try to think of something negative, but I shouldn't say anything negative, so I'll skip that part. There are other types of APIs, so this is a translation API, so you can pick the language that you want to translate to. So I'm not going to pick Chinese because you guys will be able to tell me if it's right. Let's pick Finnish. There you go, it's working. No, but this is actually pretty good. I am pretty confident. Is this working? Yeah, it's working. Speech API basically just takes my speech and convert it into text. So if you want to do something with it, then you can easily do that.
Sorry, what is the difference between speech API and NLP API?
Yeah, so the NLP API, maybe I can quickly find it for you. So the NLP API looks at text, could be a paragraph, could be sentences, and look at the sentiment on the text. So whether it's positive or negative, how strong that feeling is. So it's really good for, like, imagine if you pass tweets from Twitter into this NLP API, and then you can figure out, I should be saying this on the record, yeah, I don't know how to say it, of something, and see how is the world reacting to a particular piece of news, for example, whether positive or negative. Let me see here. Let me see if I can show you an example.
Can we use that service right now?
Pardon me?
Can we use that service right now?
Absolutely. So here's an example. Let's try this. So I'm going to stick right to the sentiment. So the example here is, this statement is fairly generic. So all it's saying is Google headquartered in Mountain View unveiled a new Android phone at the CES show. And that's very, there's no sentiment really in the statement, it's just a statement. But if I was to say, I love Android phones, let's see what happens. I don't know if this is actually going to work. Yeah, so you can see the sentiment score here. If it's from 0.25 to 1, that's very positive, that's positive, right? The closer you are to 1, the more positive it is. So you can see because I use word like I love something, that's why it's 0.8, and the magnitude is how strong that feeling is, right? And so, I do not love. Okay, let's try it. Yeah, so I have a slightly negative score. But if I was to say I hate iPhones, then maybe it'll be different. And then it also picks up entities, right? So for example, it sees that phone is a consumer good, Android is a consumer good. And those are important because let's say if you want to analyze documents and you want to pull out, say, if it's an annual report and you want to pull out who are the companies that this particular organization is dealing with, then you might want to pass an entire annual report and pull out organization. So, for example, like if I put Google in here, I think it will pick up Google as an organization, right? So that's going to help. If you want to do some sort of analytics or analysis on documents, using NLP is a great way to start. And this is the NLP API, but we also have AutoML with NLP. I think it's in alpha or beta right now, so I'll allow you to do some customization. Yes?
So that's the mission API. If you can AutoML, Google will review the network structure.
Review the what, sir?
Network structure.
What do you mean by network structure?
What kind of network, how many layers, what the parameters?
So it doesn't go down to that level of details. Let me see if I can quickly show you what you do see. The Wi-Fi. So it will show you things like what is the precision and recall of the model, but it doesn't go down to how many layers and how many.
Then if I want to use that model,
so you can use prediction. Right?
Just using the prediction.
Yeah.
As a black box.